This session we will discuss about quicksort. Okay, quicksort is a quicksort can be implemented by using recursion. Quicksort, merge sort, this follow divide and conquer strategy. Okay, divide and conquer strategy means the array is divided until we get a single element, and when we get a single element, we will combine them based on certain condition, based on greater than less than, to sort the array. Okay, now we will discuss quicksort. Okay. Okay, let us consider some random elements to do quicksort. Uh, let's consider some elements like, okay, we will use Python. Import random for, I will take list as a empty list for I in range of, let's consider 10 elements. Dot append of random dot rand int. I will take from 1 to 9 values. Okay. Okay. I will consider some random values. We will try to eliminate some duplicates or we will consider no problem. Okay. 852766. 85277649. 49. Okay. Now we should sort this by using a quick sort. Okay. For this, my goal is to place the element set in its correct position. Like there will be like pivot element that places the element in its correct position. Okay. Let us assume this as I, index 0, 1, 2, 3, 4, 5, 6, and 7. And then we will write a Python program we will try to implement by using Python program. This one assume like I. This one let this would be J. Okay. Let us assume this as our pivot element. Okay. I less than or equal to this one is A. Array of I means 8 is less than or equal to pivot. 8 less than or equal to 8 means then we will move I value I is equal to I plus 1. Again check 5 is less than or equal to 8. Condition 2, we will move I value. See 2 also less than or equal to 8. We will move our I value. 7 also less than or equal to 8. We will move our I value. Okay. Again, this 7 also less than or equal to, no, this 6 also less than or 7 also less than or equal to 8. Move I value. 6 also less than or equal to I. 8. We move our I value. 4. 4 is also less than or equal to 8. We will move our I value. Okay. 9 less than or equal to 8. Condition false. So we will stop there. Now just turn 9 greater than or equal to 8. Condition true. We'll move our J value. Okay. Again 4 greater than 8. This condition false. So we will stop. Again we will check if I is less than J only. We'll swap these elements or else we'll swap this 0 index value with J value. Okay. We'll swap this one at the end. After complete if I is greater than J, then we will swap these things J and pivot element. Then we should swap this two. it would become 4, 5, 2, 7, 7, 6, 8, and 9. Okay. Now observe one thing here. Left of these elements are less than 8, and right side of this is greater than 8, greater than 8, right of this. Okay, we got pivot element. We got this element at its correct position. So now again we will call quicksort for this. Okay. One minute, we'll check. Okay. Yeah, same for this also. Again, this one is I, this one is J. Again, we will check. This one is our pivot value. I less than or equal to pivot condition 2. I will move I. 5 less than or equal to 4. Condition false. Again, J. 6 greater than 4. We'll move J value. Again, 7 also greater than pivot. That is 4. We'll decrement J value. 7 greater than 4. We'll decrement J value. And 2 greater than 4. Condition false. Then, if I is less than J here. See. So, we should move again. Our I value, J value. Swap 2, 5. And increment I value or directly, or we can wait. Okay, then I will swap. Or else you can specify a condition I plus plus J minus minus, or else you can leave it also, ignore also. Again, I less than J is condition 2, and 2 less than or equal to 4, condition 2, it will move by itself. Again, 5 less than, so condition false, less than or equal to 4. Again, 5 greater than 4, condition true, we will move J. 2 greater than 4, condition false. Then I becomes greater than J. So I should swap this one. Yeah, where is AFJ? So this one is AFJ, and this one I should swap. This would become 2, and this would become 4. Okay, now again you can check before 4 are greater than, less than 4, and right side of 4 are greater than 4. Okay, again you can apply quicksort to this and to this left. So in that way you can do. Yeah, we will take some simple example to understand this one. Let us take 5, 4, 3, 2, and 1. Let us assume like quicksort algorithm will try to write here. Quicksort of this one is array A 0, 1, 2, 3, and 4. Passing array. This one is low, high value. Okay. Think this as a pseudocode. It's not exactly C function. So I am not specifying here in type return. So think this like a pseudocode. Okay. If you know C, you can understand it very easily. It's type of C and not exactly C programming. Okay. Array low, high. If L is less than high, then what I'm doing means I'm calling partition function means place pivot element its correct place. It will do partition of, I'm passing again array low, high in this. Okay. Then after fix sort of low to see M is placed its correct position. So I should make M minus 1 elements to correct position. I should pass array low M minus 1. Make same for this also. Find M and make correct places. If M is there, see, let us assume this as a pivot. Left than this should be less than 3. Right side should be greater than 3. Again, quick sort of array, comma, M plus 1 to high. Okay. Let us consider this example. Okay. 5, 4, 3, 2, 1. paper 31. Okay. This one is, let us assume like I, J. See, I is less than or equal to, see, let us assume this as pivot. I is less than or equal to pivot. Condition 2. I is incremented by 1. Again, I is less than or equal to pivot. I is incremented to 1. Again, I is less than or equal to pivot. I should be incremented. Again, I should be less than or equal to pivot. I should be incremented. Here still I is less than. If I again I should, if I increment I, it go array index out of bounds. Means it will cross index. Listiness out of range error we will get. So in partition, just assume partition function, that also array low I. Let us assume uh, I is equal to low, and again j is equal to I, and let us assume pivot is equal to a of low value, means starting value. This one L means here I, this one is psi j. Okay. Again I will write a loop that y I less than or equal to 5. Sorry, a of I less than or equal to 5 element, and ensure, try to ensure that I should not cross index. So I should be less than I. Then I plus plus. I am incrementing I. Okay, it will go until it get greater element. But I can do one more thing. While j greater than 5, it's enough. Or you can mention additional case, and j should be greater than L. In that case, you can do j minus minus, and when you get if low less than, we are considering ij, I less than j, then you can swap off a of I comma j value. Okay. At the end of the, see, this you should do until while I less than j. You should do. When it's done, you can when I becomes greater than j, you can swap directly pivot value, means f 0 value with f j value. Okay, and you can return j. And then return j. This is what you can do. We can take one example and we can do. Okay. 4, 5, 2, 3, 1. We will take small example. 0, 1, 3, 4. Okay. This is my pivot element initially. I value, j value. See, my first condition is 4 less than or equal to pivot. Pivot means also 4. Condition true. I will explain by I value to 1. Again 5. 5 less than or equal to 4. Condition false. So I will stop here. Now I will move on j. J greater than 4, condition false. So now I will again check if 5 less than j. Yes. Now I will swap these values. This would, there it would become 1. It would become 5. Okay. Now again I will check 1 less than or equal to for condition true. I will move I. 2 less than or equal to condition true. I will move I. 3 less than or equal to condition true. I will move my I. Again 5 less than or equal to condition false. I will stop here. Again 5 greater than is equal for yes. I will decrement my j. 3 greater than for condition false. I will come. I will check again. I will check again if I is less than j, condition false, because I is now I is more than j here. So this would become false. I will come out of the while loop because while I less than j, I will do these things. Okay. After coming out, I will swap a of j with pivot. A of j means this one with pivot. Okay. This would become 4. This would become 3. 5. Now my array is 3, 1, 2, 4, and 5. I will return this index value 0, 1, 2, 3, and 4. Okay. See, left of this is greater than less than 4, and right of this is greater than 4. Okay. This one I will return as same value, and again because fixed I am passing m minus 1, 0 to m minus 1, and here I am passing m plus 1, to 5. 0 to m minus this one I am passing again. Again I should do for 3, 1, 2. 3, 1, 2. Same process 0, 1, 2. Again I see this one is my favorite. I 3 less than or 3 condition true. 1 also less than or equal to 3 condition true. Again 2 less than or condition true, but it will I should be less than this 5 value. So I will stop here. J greater than and greater than 3 condition false. I will don't move my j. I will stay here only. I will come out of the loop because while I less than j. So now again I should swap pivot with this j value. Means 2, 1, 3. When I swap, I will return this j value. Okay. Right side of this should be greater. So there are no elements. So there are elements like 4, 5 is there previously. Okay. Again I should call these two values. Okay. When I call 2, 1, this one is same. I should call quicksort of this and quicksort of this. When I call for 2, 1, it would become 1, 2. Similarly, we will code now. You can understand very easy. First of all, array A means list of map of input. To take array dynamically, any or you can take high value means we will do that later. Here, okay, we can take high is equal to length of a array. Fixed QS, Q or QS. Fixed we can take QS, QS. Fixed of in this we are passing array as well as low value and as well as high value. Okay, if low less than 5 only, we are calling recursively this fixed. We will call this fixed recursively if I is less than low. In beginning, we will find this m value which is to be placed in its current position. So fixed of okay, comma low, comma high. This one is nothing but partition, sorry, not fixed. Partition. Yeah, TI, okay. Partition, I think. Okay, this will arrange the element to its correct place, to its sorted place. Single element is went to its sorted place. When we call this function, after that, when it is placed in its correct position, when that element is placed at its correct position, so I want to place remaining elements also. So then fix sort of array comma low to m minus 1. Yes, previous elements also I want to make sorted, and I want to place that elements in its correct position. And again fix sort of m plus 1 means after that elements to after n element also I want to place. This will call recursively. Okay. Now we will implement partition also. DF partition okay. Array comma low comma high. Let us assume I is equal to low, j is equal to high, and pivot is equal to a of l, low value. Okay. When should we move? While e of I less than or equal to pivot. and ensure that I should be less than I. Okay, I plus equal to 1, and for j value, while a of j greater than pivot and j should be greater than low value, j minus equal to 1. Okay, I'm moving I value, I'm incrementing, j value, I'm decrementing. If I less than j, then I am swapping a of phi, a of j, a of uh, j, a of phi. Okay, this should be kept inside a loop while I less than j. Okay, once we come out of the loop, when I becomes greater than j, then I should swap, means I should swap pivot element. Pivot means a of l, comma a of j value. I should swap these elements equal to a of j, comma a of l. Okay, swapping is done at the end, and I should return simply j. Okay, that is captured by m. Now I will call sort of uh, array. Initially my L is equal to 0, I is equal to I have taken I is equal to length of array, means h minus 1, means last index I am passing, and printing array at the end, star of j. That will be better. Okay, say fire. You will take some elements like 5, 1, 2, 4, 3, 1, 2, 3, 4, 5. Array sorted. We will test one more test case. 5, 4, 3, 2, 1. Okay, sorted array. We'll consider 1, 2, 3, 4, 1, 2, 3, 4, 4. It shows sorted array. Okay, we'll try to take duplicates this time. Okay, we will take these values. Eight, 5, 2, 7, 6, 6, 7, 4, 4, 9. See, array sorted 2, 2, double 4, 5, double 6, double 7, 8, 9. See, array sorted by using quick sort. It's a quick sort algorithm. Okay. This you can take a screenshot. Instead of this one, you can pass it. You can remove this line also. Then copy minus 1 also fine. Okay, now everything is good. It's hard code. Very sorted now. Thank you.